Okay, so we're looking at the second year Stats and Mechanics textbook, and we're on chapter 6, which is projectiles, and we're looking at exercise 6b, which is finding the horizontal and vertical components. Okay, so starting with question 1. So let's sketch out what they're describing. Okay, so particle is projected from a point on a horizontal plane. It's going at an angle of 40 degrees, and the velocity in that direction is 25 meters a second. Okay, so find the horizontal and vertical components of the initial velocity. So that literally just involves finding that side and that side of a right angle triangle. So that's all we're doing here is we've got a right angle triangle with an angle there of 40 degrees. The hypotenuse is 25, and we need the horizontal component. So this is adjacent. So the horizontal component here is adjacent to the 40 degrees. So I'm sure everyone's got SOHCAHTOA ingrained in their minds. So if I'm looking at the adjacent side, I'm using cosine. So that the horizontal part is going to be 25 cos 40. And then when I'm looking at the vertical component, that's opposite the 40 degree angle. So that's going to be 25 sine 40. Okay, so let's just clearly write our answers to part A. So the horizontal component, just grab my calculator, is going to be 25 cos 40. So, and let's go to 3 significant figures because that's the standard, and that's velocity, so it's in meters per second. And the vertical component is going to be 25 sine 40. Okay. And actually, I mean, part B is really just, we've already done the maths of part B. So this question is really just introducing us to this general idea. We can then give it as a vector. So if I'm looking at a vector, the I component is the horizontal is the x direction. So it's going to be 19.2 I, and then the j component is the vertical. So this is where I would include negatives as well. So the horizontal component is to the right, so that's in the positive I direction. The vertical component is up, so that is the positive j direction. So that's going to be 16.1 j, and then that's going to be meters per second. I'll just double check that answer before we finish. 19.2 and 16.1.